Good day, everyone. Here is your lecture discussion on the exogenic process. On the topic erosion and deposition. So welcome grade 11 Curie, and thank you for watching this video. Now I know that only few will view this one, and I hope that you are one of those viewing this one. So exogenic process. So for your learning targets for this video lesson, it is for you to identify the different agents of erosion and deposition, and for you to describe the characteristics of the surface features and landforms created and the processes that contributed to their formation. So weathering versus erosion. So what is the difference between these two concepts? Now, we discussed the last time the weathering, and now we will move forward to the erosion of these rocks. So by definition, we define weathering as the disintegration and decomposition of rock at or near the Earth's surface. So it occurs in situ. It means that the particles stay put and no movement is involved during the weathering process. So it is simply the decomposition of your rock. So in your erosion process, it is the incorporation and transportation of these disintegrated materials now by a mobile agent such as water, wind or ice. So as soon as the weathering product starts moving due to fluid flow, we call this process now as your erosion. So weathering, erosion, or the transportation, and deposition. When we say deposition is the settling of your disintegrated rocks or materials. No, so these are all exogenic processes, and they act now in concert but in differing relative degrees to bring about the changes in the configuration of the Earth's surface. So there are different agents of your erosions. We have running water, ocean or sea waves, the glaciers, the wind, the groundwater, and your gravity. So these 1, 2, 3, 4, 5, 6 agents of erosions are what we are to discuss today. So first is your running water. Now, so this encompasses both overland flow and your stream flow here. So factors that affect the stream erosion and deposition are, first is your velocity. So the velocity of this running water. So it dictates the ability of the stream to erode and transport, and it is controlled by your gradient. So the channel size also and shape of your stream. No? So channel roughness and the amount of water flowing in the channel also affect the stream erosion and deposition. Now, so kana siyang running water nimo, it could be that it came from a precipitation, no, from the rain. Amo nang naay na mag-flow, no, from the land padulong sa imuhang stream. So there are different types of your erosion with your running water. So we have this what we call the headward erosion. It is a process by which river erodes in an upstream direction. So pataas, no? Lengthening the river valley. Parito ang iyahang movement sa water. Whereas the lateral erosion, it is a process by which a river erodes laterally, no, side by side, no, widening the river valley. And the last type is your vertical erosion or your down cutting erosion. It is a process by which a river erodes downwards, deepening the river channel. Pa downwards pud ang movement ni vertical. Okay, so these three types of erosion with one running water or the styles. So there are different erosional and depositional landforms created by a stream. So when we say erosional landforms, we have the river valleys, no? The waterfalls, the potholes, terraces, the gullies or rills, meanders, oxbow lake, and peneplain. Whereas when we say depositional landforms, we have alluvial fans or cones, the natural leaves, and also the deltas. Now, these are your landforms created by a stream, no, from a flowing water, running water. So erosional landforms, this one, no, potholes, river, oh no, this is rills, no, meanders, and then um forgot the name of this one, but this is a erosional na landform. And then sa depositional, we have alluvial fans and deltas, natural leaves, this one, and your deltas. Ocean or seaway, the second agent of your erosion. So your ocean or sea waves is described now through its crest and flow, no, which is described through their wavelength, their wave height, the steepness, the period, and their velocity. So these waves are classified based on generation force. So it could be that these waves are wind generated waves. It could be that it is a wave due to tsunami, tides, or sieges. So some of the erosional features that is created through ocean or sea waves are the wave cut cliff, wave cut platform, marine terrace, headland, stacks, and sea arches. We also have depositional features that is created by your ocean or sea waves, which are the beach, the spit, bay mouth, bar, tombolo, and barrier islands. So these are examples of your erosional features now created by your ocean or sea wave. So this is a wave cut platform. I think this is a, what do we call that? The sea arches, kanisha, and then headland. Na yun. So depositional features, we have the pit, no, the beaches, that one. Next is your glaciers. So your glaciers, it is a moving body of ice on land that moves downslope or outward from an area of accumulation. So body of ice. So there are different types of glaciers. Now we have the valley or the alpine glaciers. Now these are type of glaciers that are bounded by your valleys or tend to be long and narrow na valley. Next is your ice sheets or your continental glaciers. So these are obviously those cover large areas of the land surface unconfined by topography. So these ice sheets, modern ice sheets, covers Antarctica and your Greenland. So remember, Greenland is a land full of ice, full of glaciers. No? And also another type is your ice shelves. So ice shelves, these are literally sheets of ice floating on water and attached to the land. So these ice shelves are usually occupied by coastal embayments, so near the oceans. Now, these ice shelves. So glaciers forms in regions where more snow falls than melts. So there are more than snow falling compared to its melting. Now, very cold regions of the planet. So snow accumulates, then goes through compaction and recrystallization, eventually transforming it into a glacial ice. So when the snow falls in here in this body of water, it slowly compacts and recrystallizes, forming later on through time no, a glacial na ice. So two types of deposits by your glaciers. So all glacial deposits are called glacial drift. We call that glacial drift, and are comprised of two types. So we call one type of your glacial drift as still. Now these are directly ice, unsorted, and composed of many different particle sizes. And another type of glacial drift is your stratified drift. So this stratified drift now are deposited by the glacial meltwater and thus has experienced the sorting action of water. So as its name suggests, deposits are layered and exhibit some degree of sorting. So it is already stratified. So the difference is that ang imong till is kanang raw pa siya bali na um na-decompose or na-disintegrate from your main na glacier. So you call that glacial drift as till ang term. And if that disintegrated part of your glacier is nasagol na siya with the action of your water, no, so na-form na siya and or sa pagtawag ani na-melt na siya, no, with the action of water. So somehow na-change ng iyang form, so we call that one as stratified drift. Another agents of your erosion is your wind. So wind erodes by deflation or the removal of loose fine particles from the surface and abrasion. When we say abrasion, it is the grinding action and sandblasting against the wind. So wind, just like your flowing water, can carry sediments such as bed load and suspended load. So when we say bed load, these are those consist of sand hopping and bouncing through the process of saltation. Whereas your suspended load are those mga sbugat pa with your sand, like your clay and silt-sized particles held high. So there are two types of wind deposits. I know that you are very familiar with these two terms. Now the dunes and the loess. So these are types of your landforms that are formed through wind movements. Now wind power. So you had dunes, which are those hills or ridges of wind-blown sand, and loess, which are extensive blankets of silt that were once carried in suspension. So these loess are most usually found in karandool sa riverbanks in ana, no, which is na dito siya ni si tawag ana na compact. No, and then kaning mga dunes ni mo wind-blown sand. Another agent of your erosion is your groundwater. So the main erosional process associated with groundwater is your solution. Now the solution of the different materials. Now, so slow-moving groundwater cannot erode rocks by mechanical process as stream does, but it can dissolve rocks and carry these off in a solution. So most likely this is your groundwater as an agent of erosion, no, does a chemical process, no, not mechanical process, just like your stream, no. So by solution, no, by dissolving some part of your rock, no, maka-travel siya og some part of that rock. So that is still considered as erosion process. So this process is particularly effective in areas underlain by soluble rocks, now, such as your limestone, so which readily undergoes solution in the presence of acidic water. The last one agent of our erosion is the gravity. So when we say gravity, we have this what we call the term mass wasting. So it is the downslope movement of soil, rock, and regolith under the direct influence of your gravity. So when we say na landslide or kana siya, movement of rock from the mountain downwards, we call that as mass wasting. No? With the influence of your gravity, that's why na nag-move ang ato ang mga material, solid material. So there are different factors that control the mass wasting process. And that includes no the slope angle, no kanang pa downward niya na angle. So for example, this one. For example, this is the mountain. So the angle of your um, slope. So the more na taas ang imuhang angle sa imuhang slope, so the tendency is mag-slide down ang imuhang soil, rock, or regolith that is above your slope or mountain. So kung mas smaller siya, ang iyahang move, kung mas less ang iyahang slope angle, so mas ingon ana siya. So mas hinay ang dagan sa imuhang rocks or soil or sa imuhang solid na mga particles. Let's erase this one. Yun. So another, aside sa slope angle, is the role of water. So the role of water, it adds weight to the slope and has the ability to change the angle of repose. So your water, no, mas makapabugat siya, and also it reduces the friction on the sliding surface. No, and the water pore pressure reduces shear strands of your material. So it greatly affects the movement of your mass wasting. So the concept of mass wasting will be expounded on the next lecture, which will focus only on the mass wasting, the different types of mass wasting, and also the different, it will be discussed more, the role of water and the slope angle in the mass wasting process. So those are your agents of erosion: the running water, the ocean or sea waves, the glaciers, the wind, the groundwater through solution process, and your gravity as your agents of erosion. So that ends our lecture for the exogenic process, erosion, and deposition. So thank you for listening. And before we end, let me leave you this Bible verse from Matthew chapter 8, verse 26. He replied, you are of little faith. Why are you so afraid? Then he got up and rebuked the winds and the waves, and it was completely calm. So thank you for listening, and be careful, or check our seeded LMS for further announcement and quizzes. Thank you everyone for listening, and goodbye.